Alright, so in this video I was going to cover how to take derivatives of the inverse functions, but I figured it would be better to go ahead and start off with implicit differentiation before we get to the inverse trig functions and other inverses. So suppose we have an equation that is not a function. So let's say we have a circle, the equation of a circle, like x squared plus y squared equals 64. Okay, well, how are we supposed to differentiate this? It's an equation and it's not a function, but we can still take its derivative by using what we call implicit differentiation. So suppose we were to take, I'll come up here a little bit, the derivative of some function of y. Okay, so it's not a function of x, it's a function of y, where y itself is a function. So the derivative of this would be d over dx times f prime of y times y prime. And I'm sorry, that would just, there would be no d over dx, it would just be f prime of y times dy dx, or y prime, whichever you'd prefer the notation, but we were using this notation before, so I'll just stick with that. So using this, and which is by chain rule, we'll use chain rule and product rule to find this derivative. Okay, so using implicit differentiation, what we'll do is we'll take the derivative of both sides. So on the left side, we get 2x plus the derivative of y squared is going to be 2y times the derivative of the inside, which is y, so times dy over dx, and the derivative of 64 is 0. Alright, and then what this will do is this will give us that dy over dx is equal to, let's see here, let's rearrange this a little bit. We get negative 2x is equal to dy over dx times 2y. So dy over dx is equal to negative x divided by y. And then that'll give us the derivative of y. So you can see, even though y is not necessarily a function of x, we can still find its derivatives in terms of both x and the original function y. Okay, so we'll try another example. This example is going to be, let's try x squared y cubed minus the cosine of xy, which equals 33. Alright, and this is what we're going to try to take the derivative of. So let's go ahead and start with this first term. So using product rule, we would have the derivative of the first, which is 2x times the second times y cubed, plus x squared times the derivative of the second, which is going to be 3y squared. But the derivative of y cubed is 3y squared times the derivative of the inside, which is dy over dx. Okay, so we have, this is our first term's derivative. And now we'll be taking the derivative of the second. So the derivative of negative cosine is going to be positive sine of xy times the derivative of the inside, which is just product rule again. So we have 1 times y plus x times dy dx again. Alright. And then the derivative of the other side is simply 0. Derivative of a constant is 0. Now using this, we can go ahead and solve for dy dx. So we'll just factor this out real quick. We got dy over dx times this whole thing. Actually, let's factor the dy dx out of here. So we have the x squared, we'll have 3x squared y squared, and then the dy dx over here is plus x sine of xy. Okay, and then we'll have a term that does not have our dy dx in it, so we'll have that 2x y cubed over here, and the plus a y sine of xy, and that equals 0. Okay, so what that'll do is that'll give us that y prime is equal to, putting this over on the other side, we get negative 2x cubed minus y sine of xy, and we can go ahead and divide that by this whole thing, which is 3x squared y squared plus x sine of xy. Okay, and that's our answer. So that's implicit differentiation for you. Basically, you're just taking the derivatives of each term in the equation. So taking the derivative of both sides of your equation.